Okay, we're going to start a series on antiderivatives. Now, antiderivative just means the opposite of the derivative. You're given the derivative function, you have to find the original. In differential calculus, we went the other way. We're given the original, and we had to find the derivative. So keep that in mind. That's what antiderivative means. It means the opposite of derivative. Power function. For now, we're just going to focus on functions that have numbers in the exponents. Not going to look at trig or logarithmic or exponential just yet. So let's read this together. A function big F of x, so big F would be the antiderivative. Basically, big F represents the antiderivative of little f. And so, as a consequence of that, if big F is the antiderivative, meaning the opposite of the derivative, that would mean if we take the derivative of big F, the original function, we'd get the derivative back, namely f of x. It's kind of weird because if you think about it, you can take any function, imagine that function being the derivative of another one. Now it gets a little complicated with certain functions trying to find its antiderivative. Some functions, I don't know that you can find an explicit one. You can use Riemann sums and stuff like that we'll talk about later. But anyways, the concept is basically you're given a function and you want to know for which function is that its derivative. Big F would be that function, the antiderivative. One way I like to explain it, let's say this is our derivative function. If we try to find the original function, and we do find it, it would make sense that if we took the derivative of the original function, we'd get the derivative back, right? So it's just a cycle, they're inverses of each other. It's kind of like the inverse of addition is subtraction, and inverse of multiplication is division. In short, if you take the derivative of the antiderivative, you get the original function back. So here's the symbol that we use for antiderivative. It's kind of like a skinny s. It just means antiderivative. If you think about it, it's just the actual opposite of d dx. Okay, so d dx is the derivative, right? Or f prime is the same thing. This would be the opposite of that. So these two have a relationship where one is the opposite of the other. This is the way I usually draw it, just a little skinny s. Everybody draws it a little bit differently. It basically means we're going to find the function that is a step up, I guess you could say, from this function, to where if that big F, the function we find, if we take the derivative of that, we get the original. Let's not get too abstract before we start to do some examples. This is how it's written out formally. If you take the antiderivative of a function with respect to x, that's what dx means, you will get a big F function. Okay. Now, we'll talk about the plus c in a second, but if you take the derivative of big F, you should get the derivative function back, little f. So little f represents the derivative function, big F represents the original. The thing is, you're given the derivative and you have to find the original. That's why it's called the antiderivative. Now, why the plus c? Plus c exists because if you take the derivative of c, you get 0 back, and the derivative of big F is little f. So basically, take the derivative of big F plus c, you just get little f back, okay? Because it's big F prime, which is just little f. I'm going to show you a graph of that to make that more clear. But before we do that, let's take a look at the constant multiple rule. We learned that the derivative of a constant multiple, like kx, is k, right? For example, the derivative of 7x is 7. Now, this is why the plus c is there, because if it was 7x plus 3, we know the derivative of that is just 7, right? So if we were given 7 and we want to find the antiderivative of that, we know it's 7x, but it could be plus anything, right? It could be plus 7, plus 9, plus 1.2, because if we were to take the derivative of that, we get 7 back, okay? So this is giving you the function where you take the derivative of this, and that's why this is called the antiderivative. You're going the reverse way. You're given the derivative of 7. The original function would be 7x plus some number, because the derivative of that would just be 7. So that's why we have a plus c. Again, k is a constant number, dx is the differential, indicates with respect to x, and c is a constant number. Without further ado, let's take a look at what the graph would look like. Okay, so here we have the graph of 7x plus 3, okay? And we know the slope of that is 7. We know the derivative is 7. And so the point is, if we were given 7 and we found the antiderivative, Could it not be 7x plus 3? Could it not also be, let's see if we can change this, 7x plus 4, 7x plus 5, or just 7x plus 0? All of those lines have a slope of 7. And so if we're given 7, the derivative, and we want to find the original function, we have to add that plus c, okay? So it could be plus whatever you want. It could be a negative number. All of these lines have a derivative or slope of 7. And so by being given, the original function 7x, by being given the original function 7, okay, the antiderivative must be 7x plus some constant, because the derivative of that would just be 7 back. Because all of these lines have a slope of 7 regardless of the c value. And that's true for not just constant, antiderivative of constants, but antiderivative of any number. That plus number is just going to shift the function. It's not going to change its slope. So be aware of that. So now we've gone over that, let's go to example 1. Evaluate the integral of 6. So real quick, most of this was actually just explaining. Real quick, make sure for step 1 it's in power form. We'll talk about that in a future example. Make sure it looks like a function that's a power function, meaning a number in the exponent and that kind of thing. Because this is k, we know it's kx. So the integral of 6 is just 6x plus c. Remember, the derivative of 6x plus c is just 6. So we have to include that plus c because it could be any number. Simplify your antiderivative if you can. In this case, we can. It's just 6x plus c. Now, you can check by differentiating. So if we differentiate our answer, we should get our original function 6 back. And indeed we do. And so, because we get the original function back, we know we must have found the correct antiderivative. So, there is our antiderivative. That was the original function they gave us. And just to clarify what the question looked like, it was the integral of 6. Or sorry, the antiderivative. We'll learn about integral later. It's about basically the same thing. Antiderivative of 6 is 6x plus c, because when you take the derivative of 6x plus c, you get 6 back.